Sustainability is becoming a much bigger question for the concrete industry, and I think we could understand a little bit about two ways that internal curing works. One is it dramatically can improve your service life. Two, it can substantially reduce the amount of cement or clinker you have in the system. So there's really a three-pronged approach: improved service life, reduced clinker, and reduced cement content that you can have that you can start to tackle here. We talked a little bit about this idea that you could dramatically improve the service life by reducing cracking. So here we can see internal curing reduces hydration, reduces porosity, and reduces the interfacial transition zone. By doing this, things move through the concrete more slowly, which means that race to get those chloride ions to the reinforcing bar is going to take a longer time in the internally cured concrete. Again, this is just showing you a picture. That crack that comes in not only hits the bar, but goes a substantial length along the bar, which can become very problematic. Cracks are going to accelerate that fluid ingress. Now, we've done, and I'll show you a plot later where there's been an analysis done with cracks. This is not an analysis that considers cracks. This is just conventional concrete versus internally cured concrete. When we were working with this with a particular DOT, they were very excited about their typical mixture. This is the service life of their mixture. So typically what you would say is the service life is when it hits this corrosion time plus about 6 years. So a typical bridge would last 23 to 24 years. The internal curing and the benefits of that are going to buy you about 4 or 5 years, plus the benefits that you're going to get without the cracking in the system, which can be substantial. Right? If you take your internally cured system and you make a slight modification, so here, this was moving to maybe adding silica fume into the system, right? Slightly more dense mixture. You see your conventional concrete moved from about 20 years to about 50 years, but your internally cured concrete moved out to about an 80-year service life. So there was a question earlier about the actual costs of the concrete, right? On one of these projects that we were looking at, the difference in cost of the lightweight was about $3 a yard. The difference in cost by the time you were done with the high performance concrete was between $8 and $12 a yard. Okay? You've gone from a 24-year service life to an 80-year service life. Right? The overall cost on this project was roughly $4,000. So just to put that into perspective, you got triple the life out of the deck for about $4,000 on a $500,000 contract. Because all these other numbers we've been quoting are the cost of the concrete. It's not the cost of the permitting, it's not the cost of the design, it's not the cost of the construction, it's not the cost of all the other stuff that goes into that. Right? Huge difference in the service life. Right? So when we want to think about this from a sustainability perspective, we've used a third of the clinker. Because we've only built one bridge, we haven't built 3. Right? Substantial impact on the carbon footprint with a relatively small change in the overall mixture. Now, I do want to point out, and I try to say this all the time, an agency that expects to get this at the same price, that is a wrong expectation. This is a value-added product. This is producing a product of greater value. One would expect that the additional attention to detail, the additional aggregate in the system, you'd expect to pay a little bit more, but the benefits far outweigh the price that you're putting into it.